Okay, this is Phys 2320 Computing 2, and this is the second video in the series on numpy. So in the first video we introduced the numpy array, or reintroduced the numpy array, and looked at creating arrays from constants, from linear ranges, log ranges and things like that. And then in the files3 video I showed you how to read data from disk into a numpy array using gen from txt. In numpy1 we also looked a lot at indexing numpy arrays, and also at how the numpy provides maths functions that work with arrays as a whole array in one go. So this time we're going to do more tricks with numpy to go and manipulate data. Okay, so over in our Spider, I'm going to start off just with the same file loading we did at the end of files3, just to get some data in. So I'm just going to run that, and it creates this array data. So data.shape, so it's 100 rows by 3 columns, and we could just quickly plot it up to show you again what it looks like. So there we go. That's what this data looks like. So you see that I'm using the second column as my x-axis and my first column as the y-axis, and then you can see here that it ranges from plus or minus 2 pi, and it's a kind of trig function basically. Okay, so first of all, before we were indexing whole rows or whole columns out at a time, just like I was doing in the plot there. There's other things we can do. So as well as indexing with a slice or a number or a list of values to give you a sublist, you can also index with a list of or an array of Boolean values, and that basically will pick values out for you. So for example, if I do data and I ask it for all rows and the last column, and if I say give me the values which are greater than 0, like that, that gives me an array which goes false, 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 true, and so on. And now I can use that to go and index the rows. So what I'm now asking for is the section of the array where the third column is positive. And that's what you get there. So in fact we could use that to plot. Let's call that pos data. And now I can do the plot again. But this time, rather than plotting data, I'll plot the pos data, which I've already selected to be just the things where the y-axis of my plot is going to be positive. And let's do that in a different colour. Do that blue. Blue crosses. Okay, and now if I go back to my figure, then you can see that I've now got just about, it's not very clear, let's plot it again with blue circles to make it a little bit clearer for you. There we go. There you go. So it's picked out just the values where the y-axis was positive. So you see it's sort of distributed over the space, but it's selected the ones that were just positive. Okay, that's fine. So that's kind of like doing a sort of, if something is true about this value, then keep hold of it. If you want to do something a bit more complicated, say if the value is positive, keep it. If the value is negative, multiply it by a half. Let's go and do that. Then numpy lets you do this with the numpy where function. So let's create a new data array, data2. It's going to be np.where, and now you see the help here telling us we have to have a condition, which is an array of booleans, and then we have x or y, and basically if it's true it gives you x, and if it's false it gives you the y value. So what we can do then is we could say the condition is where the second column is positive, and if that's the case it gives us just the data as it is. Otherwise, if it's false, it's going to give us let's say a half of the data. There we go. So in one line I'm going to loop through all the data saying if this data has got a positive y value, keep it. If it's got a negative y value or a equal to 0 y value, then multiply it by a half or divide by 2. Whoops. And there we have a problem. Let's go and select just the bits of the data we're interested in. So data 2 is now an array with y values that are going to be the same as the positive value or half of the negative values. So if we plot that, plot. So now we're going to plot the x values coming from the original data array, and the y values coming from the second data array. So data 2 is just an array 100 long. And let's give that green circles. And there you go. So you see again it's overlaid on the positive values, but now the negative values come out to be half of what we had. So in the sense we've done an if-else type of calculation with our data by using the numpy where function. So that's kind of a nice powerful thing to go and do. Now we might want to go and say that's great, let's go and stick our new data 2 column onto the our data array. So if you remember, data at the moment is 100 by 3, and then we have this other column, data 2, which is 100. And we also have so pos data in contrast is 59 rows of 3 columns. So what we're going to do is we're going to go and stick data 2 onto the end of data to make it 100 by 4. So to do that we can do the numpy column stack function. So let's create another value of data, so data 3 np.column stack, and what column stack does is it takes a tuple or a sequence or a list of the things we're trying to stack together by their columns. So that's data and data 2. So in fact let's make it a list rather than a tuple, so it's clearer that that's what I'm passing into column stack is a list of the 2 arrays, so they have to have equal numbers of rows. I'm going to stack them together to make a new data set. And there you go, see data 3 is now 100 by 4. The other thing you could do of course is you could stack some extra rows on the end of data. So here we have pos data, it's got the same number of columns as data, so we can create another data where we're going to have the rows from data, and then at the end of it the rows from pos data. So to do that, unsurprisingly, it's row stack, and the format's the same, data pos data as some form of sequence, so a list or a tuple or an array, whatever it has to be. It has just to be something which has a sequence that you can index in, sticks those 2 together, and there you see it creates 159 rows by 3 columns. So that's simple ways of building up your data. So selecting the data with by indexing, and then you can then rebuild your data with column stack or row stack, depending which way around you're trying to do it. There's a whole bunch of other methods you can use to resize or reshape data. Again, you can look at the numpy help files, but these are kind of the useful ones that for day-to-day operations. So the other thing you might want to do is you might want to go and do some calculations on this two-dimensional data. So for example, let's try and find the mean value. So we can use the numpy mean function, and I can feed it with data, and it comes out with one number. But of course, in reality, that's not much use to us, because finding the mean of data where the one column's the row, one column's the x value, and one column's the y value is not really a meaningful thing to go and do. Doesn't give you a useful bit of data. What would be more useful maybe would be to calculate the means along just the columns. So to find the mean of the first column, the mean of the second column, the mean of the third column. Probably in our case what we're interested in is the mean of the third column. What's the average y value in our data set? So we can do that very simply by using the axis keyword. And this tells us which way should you go and do the calculation along. So axis equals 0 is going to say do the means going down the rows. So if we do that, what you get out is an array with 3 elements, which is the mean of the first column, the mean of the second column, and the one we're probably interested in is the mean of the third column. Not as useful in this case, but if you wanted to find the mean along every row, you'd simply change that from axis equals 0 to axis equals 1, and it'll give you a result which is going to have 100 entries, which is the mean of the first column, mean of the first row, second row, third row, fourth row, and so on, up to the end. I say not a particularly useful calculation on this one, but it shows you the idea. So a lot of the numpy functions, when you feed them a two-dimensional array, will calculate it by taking along a particular axis. So for example, I want to sum. That's the numpy sum function. Axis equals 1. Gives us a sum going along the rows. Again, of course, that's maybe not such a useful thing, but if we looked at data 3, where we've got 2 y columns, we've got a row number, we've got an x column, and then we've got the 2 y columns, you might want to do something like all the rows, third and fourth columns. So I'm using indexing here to pull out just the relevant part of this data 3 array. This is this 100 by 4 array, so I'm pulling out the last 2 columns. I could do it like that, or I could do it like that. Either way works. All the rows, and then sum along the axis 1. That means summing along across the columns. So that therefore gives you the sum of the last 2 columns of the that array. So the axis keyword is quite handy for working with a whole array at a time. So again, the basic story here with all the numpy functions is that numpy is really designed to let you work with arrays in one go. So if you find yourself with a for loop iterating through all the rows of an array or all the elements in an array, you really want to stop and think, well, actually, do I need to go and do this, or can I go and do this in just one go? Because the difference is that if you iterate over the array, then you're basically telling Python, okay, get the number from that row, now go and do the calculation with it, and then get the next number from the row and do the calculation. Whereas if you do it on the whole array at one go, then you're allowing your computer to go and actually use the fact that it can process lots of numbers in a quick block very efficiently. And so your code ends up being a lot more efficient if you actually use the numpy arrays correctly. So numpy has a whole lot more things to go and do, and it's always worth having a look at the manual. You can just Google for it. It's in the same site as the manuals for SciPy, which is the scientific Python module we'll be coming to later. And you see it'll give you everything. This is the reference section. There's lots of things in here. So particularly things I would point out, the Fourier transform is very useful in physics. So you'll be doing Fourier transforms in Maths 4 towards the end of the semester, but it's similar to Fourier series. What you're looking at is taking a signal and saying what if I think of this as a series of different frequencies present in the signal, what frequencies are there? And so numpy can go and calculate a Fourier transform for you very straightforwardly, and then you can pick out the frequencies that are present. So if you have some periodic signal and you want to measure its periodicity or how far from being a sine wave it is, then Fourier transforms are really, really useful. Another handy one, the linear algebra. So this basically does the sorts of matrix maths that you're also going to be doing in maths in your computer. So you can do simple calculations for finding, solving equations using matrices. And the other one I would point out is the matrix library, and that actually provides support for doing matrices directly, and that lets you do all the kind of standard things you might want to do and do with a matrix, like multiplying two matrices or solving a matrix equation by inverting one matrix. It'll do all of that with built-in functions for you. I should say it is working numerically, so all of this is numerical. It's not analytical solutions it's doing. So all calculations which you do on a computer numerically are always subject to a certain degree of imprecision. And that's because at the end of the day, the computer has to represent the numbers with a fixed number of bits, a fixed precision. And that can lead to inaccuracies in your calculation. So you always have to be quite careful of this. And if you carry on in sort of computational physics, you'll get very used to having to think about what happens when you do operations with numbers which are very, very different in order of magnitude. And quite often the ways you write things down in ordinarily in maths to do operations isn't necessarily the quickest or the best way of doing it with a computer. But fortunately numpy takes care of a lot of those things for you, so you don't have to worry too much. Okay, so in this module I've shown you indexing with Boolean arrays to select data, and using np.where to go and do a kind of if then else type of selection. We've looked at column stack and row stack. I didn't actually show you transpose. So back in Python, so data.shape is 100 by 3. To transpose the array, I just simply add data.T, and that gives you a thing which is going to be 3 rows by 100 columns. So we ask for its shape, you see it's 3 by 100. So that's transposing data in numpy. I've looked along applying functions along different axes, particularly things like mean and sum. And then I've just pointed out to you that there's all these interesting other submodules in numpy that we're not going to cover in detail in this course, but the help is very good for them, and so you're aware of them. This is picking up a lot of the things that you're going to do in maths in this semester.